Okay, let's do rc2. Can we find the value of n such that rc2 of n returns true? Here's the function. Let's get going. To begin with, we know that it's got to be positive. It can't be less than 0 or equal to 0, so it has to be positive, and it can't be greater than 99. So it's a 1 or 2 digit positive number. Since we're testing for double equality against itself at the end, you don't do that with floats. Floats we use almost equal, not double equal. So n is an integer, a positive integer with no more than 2 digits. What about this line? This line's really weird because it looks like we divide by 2 and multiply by 2 and test if we don't get the original number. And it feels like you should always get the original number because you're dividing and multiplying by 2. That's not the case. Consider if you take 6 and divide by 2, sure enough, you get 3. Sure enough, when you multiply that back by 2, you get 6. But what happens if you take 5 and divide by 2? You don't get 2.5 because it's integer division, you get 2. So when you multiply that back by 2, you don't get 5, you get 4. So more generally, you can see that if n is not even, then when you divide by 2, there's a fractional part, but it's integer division, and that fractional part goes away. So when you multiply back by 2, you're not going to get your original number because you have a little less when you divide it by 2, which is to say that this expression is not equal to n exactly when n is not a multiple of 2. So if n is not a multiple of 2, we return false. The only way we get past that line is if n is a multiple of 2. So we know after this line that n has to be a multiple of 2. Well, now we do the same thing with 5. This is going to return false unless n is a multiple of 5. Multiple of 5. Let's actually test that again. What's 74? When we divide by 5, we get 14. When we multiply that back by 5, we don't get 74. We get 70 because 74 over 5, in fact, was 14.8, and we truncated that 0.8. But when we do 75 divided by 5, we get 15, multiply back, sure enough, 75. So indeed, this is testing if you're a multiple of 5. This is testing if you're a multiple of 2. There's a better way to test if you're a multiple of 2, by the way. I would say if n mod 2 is not equal to 0, that's a better test. This is if I'm not a multiple of 2. But one of the things about reasoning over code is we might give you an expression in a less obvious way, and you have to understand it. And in fact, while I prefer line 3, there are plenty of programmers who use line 4 or some variant of that. So you have to understand both ways. All right. So now, after line 4, we know that n's a multiple of 2 and it's a multiple of 5. Well, the numbers that are multiple of 2 and multiple of 5 are multiples of 10. It's the only numbers that 2 and 5 both go into. Now, having said that, we also know that n is between 1 and 99, so n has to be 10, 20, 30, 40, out to 90, one of those. Finally, we're returning that this must be true. Well, just as this checks for multiple of 2 and this checks for multiple of 5, this means n is a multiple of 7. Well, which multiples of 7 are also multiples of 10? And that would be 70. In the range. It could be more than 70, but we'd fail this first test. So sure enough, we'll simply print rc2 of 70, and it's true. So we solved the problem. Huzzah.